See if I can do the YouTube stream the correct way today. Okay. Theoretically, it's working. um, and so until or if we get a question from chat, I figured I'd start off the stream trying to get the correct answer for this integral that was on my complex analysis final. So I know it's like from Wolfram Alpha, I know numerically it's 1.3 something. I couldn't quite get it during the final though, and I'm curious what the right answer is. So how we're going to start this problem is we're going to see what the integrand looks like and consider a similar looking complex valued function. Root z squared minus 1 over 1 plus z squared. I flipped the sign of the numerator, or at least what's inside the square root, because that's just a helpful thing. That's a thing that's going to be helpful later on in the problem. We'll still get the right answer at the end of this if we don't mess something else up. And so the denominator, it has poles, but in terms of multi-valuedness, it's fine. This function is multi-valued because of the square root. And you need to think about the numerator as oh, that's not what I want to write. Z plus 1 times z minus 1 square rooted. And we're going to define local polar coordinates at each of these kind of... Like these aren't points, the things that I actually wrote, but like this... Like the z plus 1 means there's something special at z minus 1, and the z minus 1 means there's z equals minus... Oh my god. Looking at the z plus 1 bit, we're going to have a branch point at negative 1, and looking at the z minus 1 bit, we're going to have another branch point at plus 1. So we're going to define polar coordinates from those points. Why am I already getting confused on this part? I know what to do, is just the phrasing of this part that I'm suddenly second guessing. Where is a similar problem? Okay, here we go. That's how... Okay. I was about to do the wrong thing. We're going to say that z minus 1 is equal to r1e to the I theta 1. Hey, color cone. I hope you get some sleep. And then I'm going to say z plus 2 is r2e to the I theta 2. I saw in Stuki's chat. Thank you for still remembering to wish me a happy Roblox birthday despite your condition. So what these local polar coordinates look like is the first one is centered at positive 1 right here. So we can talk about any arbitrary point in the z-plane in terms of these local polar coordinates. I guess choose that point right there. This distance here is r1, the angle is theta 1. And then the other local polar coordinates, this distance is r2, that angle is theta 2. You had an oral examination? Ooh, that's good to hear. That it went well. Is that why you only slept for 2 hours? Wait, so did you do your oral examination with only 2 hours of sleep, or did the 2 hours of sleep happen after? Oh my god. Okay. I can imagine the stress of that would make it hard to sleep. I'm glad you pulled through it. Need to grind the Frobenius questions? Oh. No, I'm thinking of Perrin Frobenius, but that's a linear algebra thing. Is there just a Frobenius theorem? I feel like I've heard of that one too. Or for, okay, when I just type in Frobenius, I'm getting Frobenius norm as the first thing that comes up. Maybe that's what you're doing. Hey, Rex. We're doing well. Okay, so the first thing we want to do is we want to figure out where the branch cut is for this complex function. And the way that we've been figuring it out in this kind of applied class, we get to basically just guess and check. There's only two possible places where this branch cut. Oh, sorry, I jumped the gun. The entire point of doing this is to restrict the values of theta 1 and theta 2. We're going to restrict them both between 0 and 2 pi. 0 inclusive, 2 pi not. And so these are the things that actually define our branch cuts. We could make them point to other directions if we chose other things. Perrin Frobenius endomorphism in the freshman dream is true for finite fields. Oh, funny. Okay, and so if you were to look at both of these the square root functions individually, with these angle restrictions, they would both have branch cuts that go off to the right to infinity. But when you have multiple of them being multiplied like this, you need to check whether, like, we won't take the entire thing as a branch cut. It's possible for those discontinuities to cancel each other out, basically. And so that's what we need to check with this next bit. We're going to do what's called an A-B test, in our class at least, where there's two kind of relevant intervals to check, -1 to 1 and 1 to infinity. And what you do is you choose a point in each of those. In each of these intervals, you choose 2 points, one above the branch cut you're trying to test, whether it actually is a branch cut, and one below. So A, B, and then over here, I'll do C, D. You don't need to be particularly exact with, like, the distance from the origin isn't too important as long as you're within the interval. Raising everything to the P becomes a field morphism, i.e. preserve addition and multiplication. That's very weird. What's an example of a finite field? Oh, God. Yeah, okay. I should have guessed that. Integers mod something. Really? Oh, that makes sense because it's definitely true. Mod, yeah, like, when freshman dreams come up in previous times, like, someone always points out that it's true mod 2. It's really, so it's also true for any prime? I want to check that. Oh, by God, it does. Yeah. Binomial theorem? That makes sense. Pascal's triangle is coming in clutch for for this expansion. Wait, so what about here? Mod 4, this isn't going away, is it? Wait, dude, I don't know how, oh my god. Let's see. 4 is, oh my, okay. You raise a good point. We 220, hey, it's going good. How about you? Welcome in. You know, color code, you make a really strong point there that 4 isn't prime. We should really be using the Grothendieck prime though, right? To test this. Coefficient will contain a multiple of p except for 2 terms. It's pretty sick. And you know, 1 isn't a prime either, but it does hold for 1, you know? P choose k as a multiple of p unless k equals 0 or k equals b. Oh, you probably, that's probably not hard to show using the factorial formula, right? Hey, drug seller? Mod means like modular arithmetic. Modulus is a different thing. So actually, mod is sometimes like poor notation because it can mean modulus means like distance or absolute value, but modulo is like an operation. In programming, you might represent it with like a percent. You can do 5 mod 3, and that's just the remainder. So if you do 3 divided by 5 with long division, 3 goes into 5 once. So 3 minus 2, so you get 1 remainder 2. So that means 5 mod 3, you just take the remainder part. It turns out that's a helpful thing to be able to do in a lot of math. There's a lot of first-time chats here. I love playing chess. Welcome in. I know the basics of vector spaces if you have a question. Thank you for the follow. Yeah, I found it the hard way why you need to have it as a prime. Yeah, I've forgotten a lot of stuff that I learned in my discrete math class. There's a couple of bits that I've managed to hang on to, but discrete math is not my strong suit. Okay. So barring another question from chat, I'm gonna go back to working on this problem. How we do this A/B test thing is we look at, we're basically taking the limit as each point gets closer to the branch cut. And look at what the function value comes out to be here. Yeah, we too. If you have a question, to just ask it. Also build finite fields with p to the n elements using a different construction. Huh, okay. This is used in computer science for code corrector use for QR code DVD. Wow. That's pretty wild. Okay, yeah, that's a good question. I love playing chess, so let's talk about that. Post it in the Discord. Okay, so let me just make sure I have the definition of rank right in my head. I'm pretty sure it's just a number of linearly independent vectors. Linear algebra rank definition. So I want to make sure I don't say the wrong thing. The dimension of the vector space, yes. Okay, so let me copy paste this. So the rank is literally the number of linearly independent vectors that you have. In the columns by default, you can talk about the row rank as well. They might have a different term. But usually rank by default means columns, and so basically, since if we know the rank of a matrix, if we know A is an n by n matrix, well, we don't need to know. Can we make this more general? Can we make it m by n? I think it won't end up mattering. The columns of A are linearly independent if the rank is equal to n, the number of columns. Actually, no. It is better if we say m by n. Hey, Arav, good to see you. The rank is... And so that I'm trying to work through some of the subtleties that are in this statement here. And then I'll talk about some examples here. I think the statement is correct. And so we want to consider a few different examples here. Clonk. Well, it's okay. I don't know how to throw grenades. Hope your day's going well, Clonk. It was really nice to play with you yesterday. So yeah, we want to consider a few different cases for A. Let's consider first like an n by n matrix. We'll call it just 3 by 3. Just so we have a specific thing. No, I'm pretty bad at throwing grenades in general, but the Z was a nice excuse at least. 0, 1, 0. And then I think these should be independent. So yeah, they are. Basically, I know the rank of this matrix is 3 because I mentally just did Gaussian elimination on this. And you can get the identity matrix out of this, which means everything is independent. And so that means the rank of this is 3. And so since the rank is 3 and we have 3 columns, these vectors are linearly independent in these columns. Thank you, Clonk. You're the best, though. Also, I'd love to see the fish emote. You can post it in math in homework help or math discussion, whichever one is easier. And so the other examples that I was gonna say is like you should probably consider like a 3x2. Let's just like consider matrices that aren't symmetric. This was what I was getting tripped up on when I was thinking. Here you could do Gaussian elimination on this, and you'll get 2 pivots. And so the rank of this one will be 2, and that means these 2 columns are independent. And then you could also do, say, 2x3. Here we're only going to find rank 2, but we have 3 vectors, so it's these ones will not be independent because n3 is higher than the rank 2. Can I give an example of the polynomial space? That's one that I am not very familiar with. Color Cone might be able to talk about that. And Boston did ask about the rank nullity theorem, which rings a bell. Oh, sort of. I do remember this one. This is the right thing to think about too. Like you need your null space to have 0 dimension. So maybe not the exact thing that I would point to, but it's talking about the same thing. Oh gosh, you got a triple integral B2. We can do that. So yeah, I'll put playing chess. I'm happy to keep. Well, I don't know much about polynomial spaces, so I have a hard time talking about that. But feel free to keep talking about it in chat, and someone else might be able to help you out. Color Code might be working on something, but for now, I'm going to work on this question from We2. This one is kind of begging for cylindrical or polar or spherical coordinates. Get your final in 2 days. Oh gosh, good luck. A polynomial space, I think it's a space where like your coordinates are like 1x, x squared, x cubed, something like that, and your vectors are the coefficients, something like that. It is spherical. Okay, it's good to know. And since there have been a few, sorry, but before I get into this problem, so there have been a few new faces in chat, and whenever I do see new people who might be interested in math streams, I like to shout out that there's a whole math niche here on Twitch. I'm not the only one who does this. Everyone in the first part of the list does math help, so if I'm ever not around and you need help with a question, feel free to ask any of those people too. But yeah, so let's get into this question. So we're given that we have to do this in spherical. You came from actual education? Oh, nice. He's awesome. And let me just grab the formulas for spherical coordinates, so I don't have to guess at them. By the way, if you don't know Paul's online notes, Paul is my Jesus. He's very based. This entire website has really like good stuff for like your everything you'll see in a regular like calculus class. Oh, we also need the Jacobian. In your class, you might have different names for the variables. The most cursed thing is that in physics, they swap theta and phi. They're otherwise used the same. They just swap what letter is used for what. I'm assuming you're using the math convention of theta being the angle in the xy plane and phi coming down from the z-axis. Phi, theta, and rho. Okay. So we use the same letters at least. Hopefully we use theta and phi the same way. If what I just said doesn't match with how you use it, let me know and I'll switch. Jed, the 10 streak, your own personal Jesus. Thank you for the streak. Hey, Mouse. Okay. So I just took some screenshots of Paul's notes and I ported the formulas in here so we have them to play with. So if we want to convert this triple integral into spherical, what needs to happen? I'm a little bit rusty on these, so I'm going to have to remember what all is happening here. So these first two, we're basically only paying attention to the bounds at first. The inside of the integral, that's a straight conversion using these formulas. That's not the part that I'm worried about. But we need to translate the bounds into the equivalents in spherical. So that's going to be the more difficult part. So the inside integral is in terms of z. So these functions are like basically equal to z. So let's start by thinking about those functions. X, Y, Z. Okay, so the first thing, if x squared plus y squared, I guess root, this is going to be a cylinder with radius 1, or no. It's not a cylinder. Is this a paraboloid? If x squared plus y squared equals z squared. No, that's not a paraboloid either. You know what? I can tell you for sure that the top thing is a sphere. I'm still trying to work out what the other one is. Famistral, thank you for the raid. I hope your stream went well. Welcome in, people. Ice cream cone? Sounds good, Lucas. You can be right after this problem here. You don't think Wolfram likes this one? It should be possible to get Wolfram to do it, but sometimes it's a little bit weird. It's like kind of picky. Someone's saying this is an ice cream cone. Really? Lower one is a cone. The top is a hemisphere. This is a cone? I'm just gonna have to believe you because I'm obviously a little bit rusty on drawing my 3D shapes here. Well, we can always go to Desmos after to visualize this. Oh, you know, actually, it is going to be important to know. We are going to need the angle between the z-axis and the cone, right? You need math. You came to the right place. We're doing math right now. Okay. You're the lower cone? Yeah, it should be a 45-degree angle. Drawing just like the intersections. Like, the cone is the lower bound, so it's going to go from the cone at the bottom up to the sphere. So we don't have to draw the cone farther than the intersection. The sphere, if I'm going to rewrite that, 2 minus x squared minus y squared equals z root. I guess there's a square root, but I'm going to square each side. We can rearrange this to get x squared plus y squared plus z squared equals 2. So it's a sphere centered at the origin with, oh wait, is this an inverted ice cream cone? Or, it's centered at the origin. Stream delayed? Oh. Well, in case you didn't hear it, thank you for the raid, I appreciate it. That sounds very weird, Lucas. Directed from ChatGPT. I'll copy that down. We can talk about it more in a bit. That needs a lot more information though, because I don't really know what this would look like. Okay, I think I feel I'm gonna do this wrong. I'm gonna go straight to Desmos because I'm obviously a little bit too rusty on drawing 3D stuff. My bad. Z squared equals x squared plus y squared. It is a cone. And we only have the top part of the cone because it was a square root. X squared plus y squared plus z squared equals 2. Okay. And so yeah, the radius is root 2. Okay, okay. I'm glad I did this because I was visualizing this very wrong. There should be a clever way of doing the bounds to clean up this drawing. Square root 2? About? And then the sphere is going to be too hard to do, I think, but... That's basically it. It is just an ice cream cone. I think the start is getting the integral with respect to z and switch to polar after. Oh. You could do that too. Yeah, I guess there's nothing wrong with doing that. That's probably easier than trying to do what I was doing. We too. I'm curious to do it the way that I was doing it, but that might be an easier approach that requires less 3D reasoning. So we can do that. So yeah, integrating in terms of z, there isn't a z in there, so there's not much to integrate. We just tack a z on. So we're treating x and y like constants. And then we're going to take z and plug in our bounds. X, y, root 2 minus x squared minus y squared minus root x squared plus y squared dy dx. Okay. 10 factorial minus 9 factorial. Align with two origins? It does, kind of. Very rare math is your type of expertise. It kind of, yeah, it is, Lucas. Okay, so if we use polar coordinates here, let me get, okay, well, let me get the two-dimensional polar coordinates formula now. RD theta. And just the typical, okay, good. That's what I thought. Okay. This is a lot easier to reason about now because the bounds are way simpler. Thank you for saying that. Okay, so y is going from 0 up to square root 1 minus x squared. So if y equals root 1 minus x squared, y squared equals 1 minus x squared, add the x squared over, we get our friend the unit circle, but y has to be positive, and that's fine. So y is starting at 0, going up to the unit circle, and then x is starting at 0 and going to 1. So this is the region that we're integrating over here. So now when we want to go to polar, we know x equals r cosine theta, y equals r sine theta, x squared plus y squared is r squared. So I'm going to leave the bounds alone for a second. Well, actually, we don't have to. This is... I'm just going to choose to... Well, no, we should write the inside first and then choose what order to integrate in, because that could change things. So xy is going to be r sine theta, r cosine theta. So it becomes r squared sine theta cosine theta. This will be root 2 minus r squared. This will be minus root r squared, which is just r. And then remember, dy dx becomes r. Now we need to choose our order. I don't think the order is actually all that important here. I'm gonna choose... Oh, we're gonna get an annoying integral with the r's. So you like math the freedom you have in it? That's fair. Stuff you like the most about math is the fact that it's so weird. It might be weird from your perspective, but in math everything is possible. Yeah, okay. I'm glad that you enjoyed doing that. Let's do theta first, just because it looks easier and we can get it out of the way. It really doesn't matter which one you choose, though, here. So the bounds for theta is going to go from 0 up to pi over 2. And then r is going to go from 0 to 1. Okay. So you'll be socially successful. That's a nice one. So the reason I'm saying theta looks easier is because it has a quick u sub. We can take u is equal to, let's say, sine theta. And du is equal to cosine theta d theta. We're going to get 0 to 1. In terms of u, the bounds are 0 to 1 also. Just quickly taking, if theta equals 0, u equals 0. Theta equals pi over 2, u equals 1. This sine theta becomes u. That cosine theta cancels with this cosine theta. So we get just u r squared, r cubed. Because of that r. du dr. Now we can integrate u. Yes, I'm going to integrate u. U squared over 2 from 0 to 1. R cubed root 2 minus r squared minus r. U, yeah. And so from 1, we're going to get 1/2. From 0, we're going to get 0. So I'm just going to put a 1/2 out front. And then the r cubed I'm going to distribute into here. This first one is going to be annoying. I'm not quite sure how we're going to handle it yet. You get an integral. You get an integral. Hey, Gold. We're doing well. How do we do this one? I'd rather not do a trig sub. Can we avoid it? If I take, maybe, if I take u equal to 2 minus r squared, do good things happen? U is equal to minus 2r. Wow, u still goes from 0 to 1. That's kind of funny. Pull one of the r's in. Ooh, it's gonna get squared on the way in though, right? That might make it harder. Yeah. Time for my annual integral computation? Maybe. Happy or merry integral miss. Okay, so the thing that I'm hoping this u sub does, so this r will cancel with one of these r's. We'll have a minus 1/2 r squared root u du. This r squared we can sub. And then minus 1/2 r to the 5th over 5, 0 to 1. Minus a 4th. I think this is better. Maybe. So if u is 2 minus r squared is u minus 2? Did I do that right? Do I know math? It's 2 minus u, isn't it? Yes, 2 minus u. 2 minus u root u du. Okay. There we go. Yeah, this is actually workable now. This bit just becomes 1/10. Yeah, sorry, I didn't say that. I wasn't being very careful with my phrasing. I did the u sub only on this part of the integral. the r to the fourth part, I integrated directly in this step. You're completely correct there. Okay, and so let me actually no, let's not zoom ahead a bunch of steps. I'm going to take the root u, multiply it into each of these. 2 root u du plus a fourth 0 to 1. U times root u is u to the 3 over 2. Okay, just making sure that I haven't made any obvious mistakes yet. The 2 can come out front. Root u integrates to 2/3 u to the 3 over 2. These integrals are always so awkward. Plus 1/4 times 2 over 5 u to the 5 over 2 from 0 to 1 minus 1/10. We're getting there. We only get something from 1. The 0 just becomes 0. So it's going to be minus 1/3. 1/3. Plus, we only get something from 1. 1/10? Oh, this is bad. Do we have a sign mistake? We shouldn't have a negative volume. Well, that's annoying. Okay, let me plug this into Wolfram Alpha. Let's see if I got the number right at least, besides the sign. If it's just a sign mistake, that's a lot easier to troubleshoot, I think. Or maybe not. Minus x squared. 0 to 1. 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. Bruh. Excuse me, like... Where did we go wrong? There's no way we went that wrong. Just checking over all this work. Annoying. I don't get it. Oh, ha, ha, ha. I get it. I get it. I get it. Um, the U sub. The U sub. This is the culprit here, officer. I got the bounds wrong. When R is 0, U is 2, not 0. When R is 1, U is 1. Yeah. So, we can swap the bounds and put in minus sign in front, so I'm going to do that. So the minus sign goes away and becomes from 1 to 2. That does mean this flips. Yeah. 1 to 2, 1 to 2, flip that. All right, now let's calculate again. First I'll do those two. Wait, no minus. First these two, that's a third. 2 to the 3 over 2 minus 1. Hey, Xerxes. Minus 1/10. 2 to the 5 over 2 minus 1. What stupid numbers. Minus 1/10. Hey, JC. We can clean this up a little bit, I guess. I know the basics of latex, Xerxes, but not much more than that. Minus a third. Minus 1/10. 2 to the 5 over 2. Plus 1/10 minus 1/10. So those two cancel. Minus 1/10, 2 to the 5 over 2, minus a third. Okay, does this match Wolfram Alpha's answer? Let's find out. Two to the 3 over 2 over 3. Minus 2 to the 5 over 2. Over 10. Minus a third. Oh, beautiful. Beautiful. It matches. Okay. That was the only issue. Thank you for the question, we too. Let me know if you want me to re-explain anything, because I I definitely butchered that a little bit. Okay, I feel like I should give a shout out here. I didn't mean to stream over the top of it, but I really wanted to, like, I was planning to stream math around this time for a while anyway. So I wanted to still do it, but Zach, aka 2 he is streaming his trivia show called 16, so I do encourage you all to go over and support him doing that. I believe he just went live a little bit ago. Probably. Did he? In just under 45 minutes? Yeah, he did just go live. Okay, good. Oh, yeah. So I feel bad that I'm streaming at the same time, but I just really wanted to stream. And so if anyone does go over there, like, please do support him. I don't blame you if you leave here. Oh, like organic chemistry tutor. I've seen that channel. I haven't watched too much of it. Yes, sounds good. We too. Thank you for the problem. Lucas, if you're still here, do you want to talk about your thing? Okay, so yeah, I thought it was a little bit weird about that channel. It's a YouTube channel. Um, but he also does a lot of like calc stuff. I haven't like watched him much, but let me find the channel. It's my virtual professor. Yeah, 10 mil subs. Wow, I didn't realize like that channel was that big. Subtract decimals with borrowing. Oh, that's cool. Just like arithmetic videos here. This is a lot easier than organic chem. Holy crap. What's been going on with this channel? I haven't checked in on it in a long time. It's all about fractions now. Okay, here's some calculus stuff. Teaches at UCLA? I didn't know that. Have you met him? Okay, yeah. There's all the playlists and stuff. That's probably a better way to navigate the channel. Wow, this is like every level of math. That's actually kind of awesome. Okay, but Lucas, so you talking about your idea. So we're doing a lot of math, with background being physics. That's fair, yeah. My idea is to add a third number line between -0 and 0 with 0 in the middle. You have a good day too. No worries. So Lucas is cooking up some some wild Lucas math with adding like a weird extra number line. Like imagining it looking like this, looping around 0. And I don't know like what is on this new number line. Values like 1 over -0 and 1 over +0 are defined. You don't fucking know. I mean, so yeah, the reason why we can't define 1 over 0, like if we want to say it's equal to 2, we run into like what's the logical contradiction that we get? Like 1 is equal to 2 times 0. I guess is that just it? Because that's not true. And so what you're saying, like you're trying to get around this by making some new number. I'm gonna call it fish. Maybe we can call it L for Lucas. That would somehow fix this issue. And like I think you would be allowed to say that, you know, L is some number such that this is true and go into your own kind of land of numbers there. I don't know that this is the right intuition for it as being like between two ends of 0. Um, but yeah, I mean, I imagine you could define your own new type of complex number with this thing. I don't, I really don't know what you would do. Hey, Suas, appreciate you saying hi. Good luck with your app. Go between two ends of some random number. I'm not sure what. So why would it need to be between two, or like between two ends of one number? With nachos? Ooh, that's a great choice. That sounds great. That sounds good. Any easy proof for beginners for the Bolzano-Weierstrass theorem? I'm laughing because there's a really funny video where they wrap a proof of the Bolzano-Weierstrass theorem. I would recommend that as a way to like learn it, but it is funny and it's an opportunity to bring it up. There's like a meme among a lot of math channels. Do I have a drawing? Yeah, I do. I use it for math, but I just have a cheap tablet. A more realistic answer. Not offhand. I mean, the link is right there. It's just Bolzano-Weierstrass wrap. Little tip for cheap nachos: go to your local Quick Trip, get a bag of Doritos. They give you free veggies with the purchase of any food. Really? Huh. Free veggies. I never heard of that. Um, so you can bind it and enroll in it so normal algebra keeps working. Well, I think of like with complex numbers, you don't put it between two numbers. It's just a new axis, I guess. Oh, that's funny, Suas. Yeah, I just bought it because it was on sale on Amazon. Like, it's just a new like axis that doesn't interact with the old numbers. So it doesn't break, like there's already ways to not break existing algebra, I guess. I guess like what you're saying is a completely new idea that I don't know what it actually means, I guess. Like I think right now it's kind of lacking definition. Like a firm mathematical definition, I should say. So I like what an easy proof of the Bolzano-Weierstrass theorem for beginners. Not really. It's difficult to understand without at least some background in analysis. I definitely would not go to Wikipedia. I'm just looking at it so I have something to reference. Wikipedia is not good for learning things for the first time. Honestly, YouTube is probably a good place to go to have it intuitively explained. I don't know if it's a specific video that I could recommend. Really confused how it would be defined. Isn't this is zero? But no, that might be in some languages that might be called like Bolzano theorem or Weierstrass theorem or one of their names individually. This is the Bolzano-Weierstrass theorem is not related to that directly. This is the version of it that I know it as. And so I'm trying to remember like how this proof actually goes. I don't think it's the intuition of it is that hard. Bolzano-Weierstrass theorem. Sounds good, Lucas. Good luck. This phrasing of it is a little bit weird. This is more like the proof that I learned. I'm just reading through it again to remind myself of it, and then maybe I can explain it to you in a simple way. Okay, so I think I got it. The important thing to remember is that it's a bounded sequence. We really are going to need that here. So a convenient way here for visualizing a sequence is just a single number line, a sub n. So these are the actual values of the sequence. And if a sub n is bounded, it means that there's some lower part here and some upper part here that it can't go past. So we'll call it, say, A and B. And the point is that a sub n is an infinite sequence, but it's stuck. Yeah, sure. I hope that helps. A sub n is an infinite sequence, but it's ultimately stuck between these two bounds. So we need to draw infinitely many dots somewhere, like anywhere we want inside these two like jail bars. So I'm just kind of putting dots randomly because it doesn't matter what the actual thing is. But let's just say like we have infinitely many points somewhere around here in this part. Just throw an extra one there for fun. And so the idea of the proof is that we can bisect this interval. And no matter how a sub n looks as a sequence, either this side of the interval will have infinitely many points, or this side will have infinitely many points. We'll call this bisection point C. In this case, the right side has it. So now it's like we have a new infinite sequence that's bounded between C and B. And I'll call this one B sub n. Why not? And now we are pretty much going to repeat the process where B sub n is still infinite. We can bisect it again at a new point D. And we look at whichever side of this interval still has infinitely many points. In this case, it's the left side. I'm just doing this by drawing. And so you can just keep repeating this process. Your interval gets smaller and smaller each time. And what you're doing is you're creating, you're closing in on a limit point. Is what we're accomplishing here. That's like the essence of the proof, which is, as our upper and lower bounds become smaller, or like, I guess, closer and closer, they close in on a single point. This single point is a limit point of some convergent subsequence of a sub n. Because if there's a limit point, that means there must be a subsequence that's converging to it. Otherwise, it's not a limit point. So yeah, that's like the essence of the proof right there for intuitively what's happening. Doing this formally is harder, but that's all that's really happening. I'd probably start with the language they use in this paragraph here, or like something like this. So I'd be a little more about trying to do this myself from scratch, because it's been a minute since I've done anything with this. But you basically would start by writing out an algorithm for this process that we just talked about with taking midpoints. And then you're gonna, I guess, need this intersection theorem, or hopefully in your class you've learned something like that. I don't know if I've learned it by this name. Hmm. I'm not seeing the exact version of this theorem that I would want to see. But what I'm saying is that, like, I don't know what you've learned in your class is part of the issue with this. That's also why I don't want to write it out formally, because I don't know what you are and aren't allowed to use. Hopefully you've seen something like nested intervals that get smaller and smaller converge to a number. They don't just become empty. A sub n minus b sub n is 1/2 to the n stuff. Two things that he proved. Yeah, so that's the issue with, like, me answering this question, is that I don't know what you've been taught in class and that you're supposed to use. But I think even if you haven't, even if you don't have this intersection by name, or this theorem by name, you can probably still make this argument and just provide a little more justification for why it should be true that these nested intervals converge to a number. A way of like thinking about it is that if you have a sequence of intervals, which I saw this on the Wikipedia page where I'm stealing it from, the interval starts at 2, it ends at 2 plus 1 over k. As k goes to infinity, this interval converges to a single number. Just 2. I guess like you can just call it like a set. It like yeah. And so I guess maybe does it have to look a little bit different? Like you won't be able to use this exact example to justify what we're doing up here, but something like that. Like you probably start by naming these endpoints A0. No, not A is a bad letter. Let me say C1 or C0. We can count from 1. This is math, not computer science. C1, C2, C3, C4, and so on. And make some argument that the ratio of these terms is getting closer and closer to 0. Because we know that C3 is equal to C1 plus C2 over 2, and so on for like C4. So Cn is Cn minus 1 plus Cn minus 2 over 2. And as n gets large, this is going off in the weeds, maybe. This is a recursive sequence. I'm not sure if this is what you want. But I don't know. I might just leave it there. So I might be making it more complicated than it needs to be here. Hey, Dora. Nothing much in particular. This is basically a free day. What we're talking about right now is the Bolzano-Weierstrass Theorem. Trying to talk about how we could potentially prove it for I love playing chess. Same recurrence he used. Okay. So yeah, there's something in that that's getting a little bit like complicated, but you'd want to say something about those getting like converging just to a number. It doesn't matter what the number is, but it just needs to converge to something. But yeah, we're just talking about Bolzano-Weierstrass theorem. I'm probably gonna, if there ends up being downtime, I'm gonna try to do an integral with branch cuts and complex numbers. But yeah, mostly a goofing off day. Okay, so I might leave that here. I love playing chess. And move on to something else, unless you want to ask me another question. I hope I at least like have set you off on the right foot here. I'm not sure how to really proceed with that is the issue, and I also don't know if that's even what you should be doing in your class. Like, I'd rather leave that part of the proof to you because uh, I also just feel like I'm writing the proof for you, and that's not like a helpful thing for like it's better if you try to do it yourself because if I just do it all for you, I don't think I've really helped you. Studying for an optics exam today. Did you know we use? Ooh, I have heard of Fourier transforms in optics. I don't know anything about them though. Like, I'd love to learn more about it. Yeah, but I don't want to just prove it for you. I love playing chess. That's not like the point of why I'm here. Like, I would encourage you to pick up where I left off here, or look up some videos or some like other like research on Google, like I just did. But I don't know if I just like I know I don't want to just do it for you. Thank you for understanding. An image like a photo in your camera roll or whatever can be built up by some simple planar waves, just a function be built up by simple harmonics. That makes okay, yeah, that makes a lot of sense. Yeah, if light is just waves, anyway. I think it piqued my interest a long time ago. I had someone send me a book about I think it was called like Fourier optics. Like, ooh, that sounds kind of cool to learn about. Let me see if I can find it. I really want to learn more about waves in general. I feel like it's a part of my knowledge that's really lacking. Found it. Let me bring it up. Introduction to Fourier optics. This is a hell of a textbook cover. Yeah, this would be a cool thing to learn about someday. Dang, this goes on. Holography? Whatever that means. Fraunhofer, my goat. Treat light as rays, vectors, figure out where it goes. Treat it as an E&M wave, find intensity, power. Treat it as photons, quantum stuff. With this you can build telescopes, lasers. Ooh, wow. That's interesting that you consider it in like three different ways like that. Oh, wow. We just immediately get presented with a functional here. Is this a functional? Yeah, it is. Oh, this is a Fourier transform in 2 dimensions. Okay, that's not that bad. Oh god, you know it's engineering when they use J. Blah. Blah. The exact equations used today? Nice. You love J? That's fair. We've been like using 2-dimensional Fourier transforms, but we never actually defined them. In one of my classes. Like we defined 1-dimensional, but like I've always wondered how 2-dimensional Fourier transform should look. I guess this answers my question. Sort of. I feel like it would look different in a math textbook. Two. Why are f sub x and f sub y variables? This notation is a little confusing. F sub x times x? But f sub x is also an independent variable? Oh, a frequency. Okay, that's fair. I thought, okay, yeah. Okay, that's fair. Ooh, they use a Gaussian for their direct delta function. The one that I was taught was just like a constant function centered at 0, but cut off. Yeah, waves in 2D seemed like an entirely different animal than waves in 1D too. Dang, they're just hitting us with every single formula in the book right now. What is happening here? This is a lot. The Fourier transform. Is this it's almost like a convolution of a function in its conjugate, like complex conjugate. I don't know. Okay. Oh, they even go to Hankel transform. That's another one that I've wanted to learn about for like polar coordinates. We did not get this deep. Okay, that's fair. One day I'll hopefully get this deep. I recognize a good amount of stuff that was going on in that mathematically at least, but I am pretty weak on like a lot of that stuff. Okay, unless someone wants to ask a question, we might go back to doing this integral up here to kill some time. Have something to run our mouth about. So what was I doing with this thing? I was doing an A/B test to prove where the branch cut is for this complex valued function. So at the point A, oh, you know what we should say? In polar coordinates. Sorry, this function in the polar coordinates we defined here. We should actually talk about that. It's going to be r1, r2 to the 1/2, e to the I, theta 1 plus theta 2 over 2. And then 1 plus z squared is z squared minus 1 plus 2. So it's this same thing plus 2. I didn't mean to do that last undo. Oh wait, no, I'm stupid. There's no square root. This plus sign is really annoying me. Plus 2. There we go. Okay. And then this is the thing that we're going to plug in values for the A/B test over here. So at the point A, R1 is just whatever. We don't really care about it. Same with R2. The thing we really care about are the thetas. Theta 1 is measured from here. So theta 1 is measuring an angle of pi. Theta 2 is measured from here, which is measuring 0. So that's what we get. You can simplify that a little bit. Now let's look at B, which is right below A. The point of this is that we want to see if they have the same value, depending what... basically, if we think something might be a branch cut, we approach it from above and approach it from below. And if we get the same value, it is not a branch cut, because that means it's continuous. If we don't get the same value, it means it's discontinuous, so it must be a branch cut. Okay, so then theta 1, again, measured from here. For point B, it's still measuring basically pi. But theta 2 is now going to measure 2 pi. Is the big change here. So now we get r1, r2 to the 1/2, e to the I 3 pi over 2. Or r1, r2, e to the 3 pi I plus 2. And these are not the same thing. Wait. Yes, they're not the same thing. This one has an extra minus sign in front, because e to the I 3 pi over 2 is the same thing as minus I, and this thing is plus I. And the denominators are the same. So might have found something halfway interesting because you're getting a real connection to math. Okay. What is it? Buckle up? Okay. Oh. Always see your chat. I'll keep on doing this. So at point C over here, Theta 1 is measuring 0. Theta 2 is measuring 0. It's going to get a whole bunch of zeros, or ones, I guess. Not even going to bother writing it. So at the point D, just below it, they'll now both be measuring 2 pi. And the point is, these are also both going to be positive ones, so we're going to get the same thing. So because it's different across A and B, there must be a branch cut there. Because it's the same across C and D, there's not a branch cut there. So we're not even into actually integrating anything yet, but we have to determine where the branch cut is, which is between -1 and 1. Okay, let's see what Lucas is cooking. Yeah, the special number a, which is actually just a letter, but for the sake of it, let's call it a number. A equals 1 over 0, B equals 2 over 0, C equals 3 over 0. Okay. A times B. A is equal to omega, B is equal to 2 omega. Okay, yeah. D over 0 is equal to C squared. Well, it shouldn't be just D equals C squared. So if A equals 1 over 0 and A equals omega, hopefully that means 1 over 0 equals omega. And so if D is 4 over 0, well, shouldn't it be B squared? Yeah. And so I guess this is kind of hinting omega squared equals omega. Hmm. Hey, lonely me. I'm trying to think of where, like, what direction you could bring this. Um, I am maybe a little bit worried about a statement like this. It might be almost like limiting. Because I'm thinking like if this does have a use, it might be with like describing how functions blow up to infinity. Where that okay, yeah, let me back up and say that part. If we're going to say a statement like this, D equals 4 omega, B equals 2 omega. So if this is true, and if this is true, then we should be able to square both sides of this. So B squared is equal to 4 omega squared. So in order for 4 omega squared to equal 4 omega, it should be that omega equals omega. Or omega equals omega squared. I mean, it could be a good thing or it could be a bad thing. I'm not sure yet. Depends what we're trying to do, I guess. And so peculiar, which makes me scared. Hey, you're the one who specifically said you like doing weird math that no one else does. um so I guess I should also say I do like your introduction here, which is it is just a letter. We're trying to treat it like a number so it can be useful, but like omega is just like markings that mean 1 divided by 0, I guess. I think that's a good attitude to have with it if you're going to try to do something with this. So if I don't know if it's even the right thing to do, but like what about the number like 4 minus 3 omega? Does this mean anything? Yeah, I mean 4 minus 3i, it at least it has geometry where you can if you wanted to take 4 minus 3i somewhere out here and like rotate it around somewhere, you could do that with complex numbers. And I'm trying to think of some kind of equivalent that might be with this omega. Linux physics. Physicists do this all the time. They shuffle unknown weird stuff into a variable. That's how they do renormalization. That's funny. Yeah, I'm thinking of like dual numbers when we're talking about stuff like this, complex numbers. I haven't heard of like renormalization like you're referring to, I don't think. I don't know, like if I took this and multiplied it by some other number, like what do we get? 4. Assuming I'm making a lot of assumptions about how arithmetic is done with this number, but I assume this is more or less what you had in mind. So we're saying, oh, this is kind of a weird multiplication. If we do take omega squared equal to omega, this would become 4 minus, what the hell? Like, these two would just cancel if omega equals omega squared. Is that a coincidence? Oh, wait, did I even do this right? No, I can't, wait. 4 times 1. Oh my god, that's an, I don't know how math works, dude. It's an 8. They don't cancel. Okay. That'll be minus omega. Okay, that seems more reasonable. As reasonable as this can be. Point is to determine what property it has. True, yeah. Spun for complex I when people do not believe. Yeah, and so like this isn't the first time Lucas has brought up an idea like this. And I'm really out of my depth with trying to figure out anything about this, but it would be neat if you could figure out something useful to do with this. Remember in real algebra this would be infinity. Multiplying would just be infinity still. Yeah, and so that's another thing that's in the back of my head where like by even making this statement here, I've implicitly done like 8 infinity minus 9 infinity equals negative infinity, which you normally wouldn't make that statement. Like infinity minus infinity, it shouldn't be anything. This is like, you know, not on firm ground. Maybe multiplying 2 omega numbers makes the number move. I guess the word move is a little weird. There's some multiplying is okay. I wonder if this would be more interesting if we did not say omega equals omega squared. So it means we would not have this equality. I don't think. And it would change this math here. Which I've still done infinity minus infinity here. Yeah, blank space. That's a good way of thinking about it, because I think that's kind of yeah. So I guess with that in the principal value sense, it's okay to do infinity minus infinity with that kind of direct delta argument. I do think we should get different like behavior if we square this though. That just seems like it's new and different. So I'm also thinking of something like the moment as x goes to infinity, of x squared over x is infinity, whereas the limit as x goes to infinity of just x over x is 1. So like kind of like the rate at which you go to infinity is important. So that's why I'm saying we should keep squared things separate and higher. Whatever's new and different is interesting to look at in a new type of algebra. Yeah. Hey, ultra products. This is just some really cooked math that we're just toying with for fun, basically. This is an idea that Lucas had that we're seeing if we can either make it interesting or find a contradiction. The idea is that I guess we're basically trying to make it like complex numbers, but instead of I equals root minus 1, we have omega equals 1 over 0. That's kind of how I'm treating it, at least. I don't know how to answer the question when it's which of the ring axioms are we dropping. I guess actually maybe I do know how to answer that. I guess so maybe are we adding one where like multiplication does have to have an inverse for every element? And we're trying to make that work. But I'm not that strong on rings, so I might be thinking about this wrong. It's about to be my life goal, dog. Existence of inverse might be suspicious. Yeah, it's like, what is 1 over omega? I guess that's 0. Or even just saying omega minus omega. I don't know. We can't keep all of them because you can prove that the only ring where 0 is an inverse is the trivial one, and we don't want the trivial one. Well, we're theoretically talking about a new set of numbers, though. Does it matter what... Is that proof for all sets of numbers? One over omega plus 2 over... Ooh, that's an interesting question. I'm inclined to say 0. Like, these are both individually 0. I don't know, though. Want something like this that cannot actually satisfy the ring axioms? Well, yeah, Lucas. All of this is just us making it up out of nowhere, though. I don't know. That's a good question about, like, what if you want to divide by omega? Actually, I guess you're right. It's not going to be that simple. Like, I think you need to keep the powers, because like, what about over omega squared? No, maybe that's still 0. In ultra products, you're probably right. I'm just trying to get through this intuitively, I guess. I only sort of know about how rings work in the first place. And I'm not much of an algebraist or abstract algebraist, so I'm just kind of making this up. Yeah, sure. Links are turned on. Yeah, dual. I probably looked at that page before. I know they have it for like whatchamacallit, square root of 1 is a popular one, or square root of 0. Maybe I was getting mixed up with that. Yeah, I think I've maybe looked at this before. Yeah, Lucas, I guess I'm kind of thinking in terms of the limit argument that I was saying before, it probably should equal 1. Because like limit as x goes to infinity of x over x equals 1. But then like if we're just making this limit, I feel like the omega thing isn't necessary. Like I guess I don't know if these would be any different than just talking about limits. So I don't know. Omega over omega equals omega times 1 over omega. Yeah, I guess times 1, like 1 is still the identity here. I assume that's a thing that we would want. Oh yeah, okay, and that's a little bit weird. I was misreading what Ultra Products was saying at first, but like it's omega over omega. I think it will be written on paper like omega times 1 over omega. I was reading it first the other way around with like omega times 1 over omega. Uh, yeah, I guess this is like an infinity times 0 situation. Division even mean in the first place because 0 over 0 is not 1. Yeah, I guess we just, since we're taking multiplication to be similar, I guess we're assuming that division is similar too. Or like just the inverse. We have assumed a lot by doing this, but you know, it's just playing. Hmm. I don't know. I guess I would imagine we could call this 1, but if we had say omega times 1 over omega squared, that's, I don't know, maybe that's 0 or infinity. I'm getting this mixed up. No, 0. 0. So I don't. I think this has just kind of ended up just being a placeholder for limits going to infinity. Like, I'm not sure this is actually anything new, the direction that I've been steering this. Omega equal to slash omega squared? Maybe there's a number missing there. Oh, not equal to, yeah. Okay. Omega over 0 is not equal to omega times 1 over 0. Oh, this is a weird one, though. I feel like they should be equal. I don't know. I guess so, yeah. Well, math ring. Abelian under addition. We're gonna keep that. Monoid under multiplication, which we can maybe compromise on. Actually, it's probably gonna have to be that one. Associative. I don't know. Yeah, lonely me. Post it in homework help or math discussion. Whatever one is easier. And if I don't see it when you post it, just let me know in chat. 'Cause, I sometimes miss posts in my Discord. So at least what Ultra Products is saying, Lucas, is that in order to have a chance at having a consistent system of math, we need to drop one of these things here and not assume that they're true. I'm going. We might need to drop the inverse thing. Zach, thank you for the raid. Who's the champion of champions? Sorry, I didn't realize that you were planning to stream at the same time. I hope it went well though. Gold murdered all of us. GG Gold. The Gold set many new records. Wow. Okay. Well, it sounds like it went well. What we've been talking about here is Lucas has been cooking up some math. We're kind of toying with this idea of, can we define a new version of complex numbers, but instead of I equals square root minus 1, we have capital omega equals 1 over 0. And just, we're trying to see if we can make that work and make it make sense. So far, we haven't been very successful. But yeah, we're just looking at the definition of a ring and add a suggestion from Ultra Products and trying to choose which one of these properties to drop. It was super fun. Awesome. Using the ring axioms, you can prove 0x equals 0. So if 0 is multiplicative inverse omega, then for any a equals 1, a equals 0 omega. I see Lonely posted a question. You already have the answer to these, but you've watched videos in SAI, they always get different answers. Okay. I think we'll switch gears and work on Lonely's question, but we can still come back to this one. And if you guys want to keep talking about it in chat, please do. But it looks like we have some trig to take care of here. Let me get some water. Yeah, please do, Lonely, because after looking at this, there's actually infinitely many right answers to these first two questions, at least. Going out for dinner at a Thai restaurant with some friends. Ooh, enjoy. Sounds good. Yeah, so I would argue these questions aren't very specific. Where we could find it as many answers as we want. Yeah, it's something like that, ultra products. But there's like a bunch of different forms of that identity that you could use. And you can always add 2 pi to the angle, so. Pad key mao, extra spicy? Oh man, Thai food, you gotta be careful asking for extra spicy with Thai food. Yeah, that's like a different level, but good luck to your digestive system. To do without using formula if that's possible. In a cast way? Yeah, I can give you the page. Oh, cool. Thank you, Ultra Products. I don't know if I've heard the acronym CAST. But the idea of like this identity here, sine theta equals cosine theta minus pi over 2. Like we're just looking for any way to relate sine to cosine. To find where it's positive and negative? Okay. Oh, I might know. Okay, yeah, I think I might know what that's talking about. Let me bring up a unit circle. That's probably a better way of explaining it. If I'm thinking of the right thing. That's not good. Find a better one. There we go. Review one of your favorite math subgenres? Ooh, it's a good one. Okay, so the way we have sine, we want to write in terms of cosine, but we need to figure out a way to shift it so things match up. So, oh, I think linear algebra is great. I guess it's not for everyone, but you can study abstract algebra without studying linear algebra. Um, eventually, okay. So sine is positive up in the first two quadrants. Cosine is positive in the left two or the right two quadrants. I know my rights and lefts. Don't worry. Oh, I mean, eventually in linear algebra, you don't talk about vectors physically anymore. They're just kind of letters. If that makes you feel any better. Oh yeah, it becomes less and less spatial the more abstract you get. As I think. Cosine is positive. Sine is positive. And so really? Oh, ha. Okay, wait. This is I don't like the exact way that they wrote this formula. I'm going to get to it in a roundabout way. Wait. No, okay, this is like a subtle thing to get right, so I'm trying to do it the right way. Obi, I bet you could just like do this in a snap. It's this is both trig and transformations, which are two things that can be a little tricky. Lonely Me in chat asked, they already have the answers to these questions, but like they keep finding different explanations. I think because there's so many different ways of doing this. And so I'm just looking at the first part for now. Rewriting sine 7 pi over 3 in terms of cosine. And the answer key does it like this. And so Lonely Me asked for a kind of visual justification of this. And I'm trying to come up with that right now. And so they use an acronym called CAST, which I haven't heard of, and I'm trying to guess what that must be. Maybe I could Google it. That might be better than me trying to guess. CAST trigonometry. Oh, cosine all sine tangent for where they're positive. So this is the A, this is the C, this is the S, this is the T. Cast. Okay, that part makes sense now, at least. Yeah, it is a weird order. For whatever eats its way pi equals. Yeah, and so it'll be, yeah, the question isn't phrased very rigorously, right? Like you said, like I prefer your phrasing with like the coterminal angles. But yeah, so Lonely Me, that's what was confusing me too with what they wrote. The way it is typically written is sine of x is equal to cosine pi over 2 minus x, like you say. Well, they do a second identity on this cosine. Because cosine is even, you know that cosine of x is equal to cosine of negative x. So for free, you can just stick a negative sign whenever you see a cosine inside of the parentheses. So what they did is they said that's equal to cosine of negative pi over 2 minus x, and then they distributed that negative sign in. Like that. So it's the same identity. They just kind of like it's still valid, but they kind of skipped a few steps. Right, let me fix. Yeah, that's the justification for why like this formula is the default one, because it's like different sides of a right triangle. Yeah, okay, I really like that Linux physics. Thank you. I've had the realization before, but I forgot about it. The reason why we usually write this is just looking at a generic right triangle. If this is angle theta, A, B, C, this other angle is pi over 2 minus theta. Just because the angles in the triangle add up to 180. And so sine of theta is equal to B over C. Oh, that's not B. B over C. And cosine of pi over 2 minus theta is the same thing. B over C. So that's why they usually show that form of the formula. But if you play around enough with trig formulas, you can get many, many different forms of the same thing, which is why it gets confusing. We know which are which by the sign being up, down, plus or minus, cosine being left, right, plus minus. Right. Okay, yeah, so that's why that identity is true that we started with. And so the reason that they do the flippy thing, like the reason that they did this step with inserting the minus sign is because when they go to apply it, let me just do it with a fresh thing up here. When they go to apply it here, cosine pi over 2 minus 7 pi over 3. This is going to end up being a negative number, and they just wanted to avoid having a negative number. That's the only reason why they did that. You could just always apply the identity that we talked about with pi over 2 minus theta, and then at the very end, flip the sign if you get a negative. Getting common denominator. So here, I did not do the sign flipping thing, so I'm going to get negative 11 pi over 6. And now I'll use the fact that cosine is an even function to get rid of that negative sign. I think this is a more intuitive way of doing it. Cool, then it's up matching. Yeah, Dora, that's the extension I was originally going to go for. I just can never remember which direction the shift goes. Awesome. Glad to hear that makes more sense. So I would say that this cosine problem is the exact same thing. Why? What? I'm not sure what this explanation is. That seems a little weird. I don't see a reason why we can't do the exact same. Like I'm pretty sure we have the reverse of the other thing. Like cosine theta is equal to sine pi over 2 minus theta. I guess we're gonna get a negative number, aren't we? Okay, yeah, I'll show you a different way of. I don't know what way they did it, but the way that I'm gonna do is definitely different. Interesting. Yeah, I was gonna do the 2 pi thing. I was wondering if I should have done it up here, but I guess it ends up not mattering. It's just another thing of there being many different correct answers. Okay, so I'm going to use this identity here just because it matches what we did in the last problem. So cosine of 5 pi over 4 is equal to sine pi over 2 minus 5 pi over 4. Common denominator again. It's 2 pi over 4 minus 5 pi over 4. Exactly, minus 3 pi over 4. And so sine does not have the same identity as cosine. We cannot just chop off the negative sign. Yeah, that's true. Like, this is technically the right answer right here, because the instructions aren't more specific. I assume your teacher still wants something that's positive, though, so we can still fix it. But I think the instructions are kind of poorly written here. So, minus 3 pi over 4, this is where I would go to the unit circle. If positive 3 pi over 4 is here, so if we want to figure out where negative 3 pi over 4 is, we start at 0 angle and go down. Like, to get to 3 pi over 4, we start at 0 and go up. Here we're going to go down 3 pi over 4. And it's going to end up being 5 pi over 4. So if you don't have a unit circle, the way to figure it out, just like with pen and paper, is take the angle and just add 2 pi. That's essentially what we've done here. So you can always, when it's inside of a sine or cosine, you can always add 2 pi and not change the value of it. It's a nice property of sine and cosine. For tangent, it's just pi. Eight pi over 4. Sine 5 pi over 4. Use power series. Cosine and exponential form, then mess. And so if your next question is, why couldn't I have done this plus 2 pi thing up with the cosine problem? You could have, and you would have gotten a different answer. That is also correct. That's why I don't like this question. It's too vague. So I guess we've kind of shown you two different ways of doing a problem like this. This thing with a cosine chopping off the negative, I think, is less universal. If you're only going to remember one thing from this, I would remember this method here with adding 2 pi. And the visual kind of way of adding 2 pi is it's basically accomplished like what I showed you here with going downwards. It is important too. I get you there, but I just mean for doing more of this type of question here, I think it's more general to remember this way. But they are both important. Yeah, good. Perfect. Cosine even, sine and tan are odd. Okay, what's going on with number 2? Write an equivalent expression using the related acute angle. I guess we're going to do pi minus the angle? And we're going to need to do like cotangent or something. What is the answer? Tangent. Oh, don't do this. What? 5 pi over 3. It's 5 pi? Okay, yeah, 5 pi over 3 is down there. Tangent 2 pi. Wait, 2 pi over 3 is... Am I crazy? That's not acute. Are you telling me 120 degrees is an acute angle? Am I... Acute is less than 90, right? I'm not crazy? Acute angle. Yes, between 0 and 90. What the heck? Yeah, so I really don't like the instructions for this problem. um Okay, I think I figured out what they're trying to get at though. If they just want us to be in the upper quadrant instead of the lower quadrant. That's oh my god. Okay. Or like the sorry, not quadrant, but half. Like if they're giving us an angle down here and they want us to get up here, I guess we can do that. I haven't gotten to part B yet. I don't know. That doesn't seem right. And I'm sorry, wait, I assume this was the answer key. If this is your work and I'm criticizing it, I'm sorry. I don't mean this is like a slight on you if this is your work. I'm just like, okay. So I just want to make sure that I wasn't making you like feel bad because this is just a confusing assignment. You're very right to be confused about this. Okay, so I guess what's happening on the unit circle is that we have an angle down here, and we just want to find an equivalent version of tangent up top, I guess, because in this quadrant, tangent is negative. Here it's positive. Here it's positive. Here it's negative. So there should be something that we can do here. We're definitely going to be up here in this quadrant. I guess for this one, I would just say, like up here in this problem, we were able to add 2 pi to sine just for free because the period of sine is 2 pi. The period of sine is tangent, and so we can, sorry, the period of tangent is pi. So we can add or subtract pi as much as we want and not change the value of it. So tangent of 5 pi over 3 is equal to tangent of 5 pi over 3 minus pi. Yes. So we just get tangent of 2 pi over 3. Yeah, I would prefer a negative angle or a negative sign somewhere here to ultra products. But if 2 pi over 3 is the answer, this is how you can get to it, I guess. I agree. I think this is just wrong. I remove the word acute and like replace it with like an angle between 0 and pi or something. That's how I'm really interpreting this question. Yeah, I have a lot of issues with how this homework is phrased. Perpy. Yeah, okay, what is perpy? Sine of 4 pi over 3. We're getting 5 pi over 3? Okay. 4 pi over 3 is right there. So these do have the same value for sine. Welcome back, famous troll. Wow, I really hate this problem. This is so poorly phrased. How can we justify going from 4 pi over 3 to 5 pi over 3? It's pi minus 4 pi over 3. That's how we're gonna do it. Or no. It's something like that. BRB? Okay, no worries. I need to figure this one out anyway. Tesla creating a program in physics, an object that is in motion is said to have kinetic energy. Okay. Question for my omega thing. Can I say that if omega is the inverse of 0, then omega or omega equals 1? Because if omega is the inverse of 0... Hmm. Maybe I'm worried that I could somehow find omega over omega equals 2 also or something. Or maybe ultra products has a better contradiction, potentially. I'm not sure. Okay, Lonely Me is back. I had... This one is really annoying. I'm trying to remember the... uh, I don't know why I'm getting confused with this. I'm trying to... I don't know if there is a formula. I'm trying to remember how this works. Like, you definitely have to do this calculation a decent amount. But I'm trying to remember how it actually works. What? I have no idea what the hell this is. I don't know why that makes no sense. Like I think what they want you to maybe what they want you to do for number 2 in general is just on the like for sine there's 2 places where sine equals negative root 3 over 2, which is 4 pi over 3 and 5 pi over 3. They gave you 4 pi over 3 and they just want you to find the other spot where it happens. And for whatever reason I can't remember like what that's called or how you find it. Does okay? Let me look at Paul's online notes. He might have a problem where he does this. Okay, Discord. I guess this is the mirror symmetry. Principal angle sounds right. Or I guess these look... Right, I'm just trying to remember how we should use them. Himanshu, I guess example 2 part B, it's not, the question isn't phrased right. They want you to get 5 pi over 3. It's a problem with pi over 3. So I don't know how to phrase this right. Basically 4 pi over 3, it is, in terms of signs, it is just like pi over 3 as an angle. It's just the negative sign that's wrong. And we know that sine is negative down here in these 2 quadrants. So I guess you could do this as like a two-step process. One is to get the principal angle for 4 pi over 3, or whatever it's called, and realize that it's like pi over 3. And once we have this pi over 3, we want to translate it down to quadrant 4. Because that's where sine is negative, like the other spot where it's negative. So if you're in quadrant 1 and want to get to quadrant 4, you should add 3 pi over 2? And hopefully that works. Pi over 3 plus 3 pi over 2. Oh, that's not good. Dude, why is this so annoying? Yeah, I can do complex analysis, but I can't do trig. That's what we're finding out right now. Okay, no, I'm sorry. Once we know the principal angle is pi over 3, we want the same angle but coming down from 2 pi instead if we want to get into quadrant 4. So what you should do is 2 pi minus pi over 3. But obviously it's really confusing, and I don't blame you for being confused. Thank you for the bit. Yeah, I'm sorry these questions are like, a big part of this is just that they're phrased really poorly. Like, this would be a lot harder to trig is already a tricky thing, and it's a lot harder to learn when they're just using the wrong terms. Like, I think acute angle is completely wrong to say here. And the first one is just vague. It's not necessarily wrong, but it's vague. Sine pi plus pi over 3 equals sine 2 pi minus pi over 3. Maybe Himanshu? Yeah, that should get the right answer. So yeah, Lumi, I'm sorry that wasn't like the best explanation for that last part, but I feel like we at least made some good progress with the other questions, or at least like we did the other questions well. JC, we were just doing this kind of worksheet from Lonely Me. The thing we were stumped on was example 2 part B. I think the phrasing of the question is just wrong. They asked for the related acute angle. The answer is supposed to be sine of 5 pi over 3 though, which is not acute. And so I was trying to come up with a justification, or like for like how you, like, it is true that sine of 4 pi over 3 equals sine of 5 pi over 3, and I was struggling to get the justification for why. I eventually got it, but it's not a very good explanation. So I have to spend way too much time of their time chasing down negative signs? Yeah. Also can be proven by adding minus x. Oh yeah, that's for Lucas. Ugh. So yeah, I guess thank you for the question, Lonely Me. I guess I'll leave it there. Sorry you have to do problems like that. Let me know if you have anything else. Oh, and thank you for the 6 bits. Average Degrees fans versus average Radians enjoyer. I'm definitely on Team Radians. Let me catch up with what Lucas was saying in Ultra Products. A plus 0 equals A in distribution. Hmm. Um, Getting into additive inverses with this. Uh, I mean, it does seem like we should care about addition. Unless you never want to add omega to anything, and you're only ever multiplying. Or like, if you want to be able to add omega, I guess you kind of need to define that. Or like, you, 0 is important if you ever want to do addition involving omega. Maybe JC. This is just a thing that Lucas has been kind of toying with. Basically the idea is if we can define complex numbers with like I equals square root of -1, could you do something similar with this omega equals 1 over 0 thing? And so we're trying to see if we can make this actually work. I bet the answer is probably not, but you know, at least like figure out why. Or if you get something that works, probably not very useful. Yeah, Lucas, for a ring, you need like 3 essential things. A ring has a set of numbers and 2 operations. Those are the things you need to define in order to possibly have a ring. They need to have certain qualifications that they meet. But the trivial ring is just has the set of numbers as just 0. So you're always allowed to do 0 times 0 and 0 plus 0. Like 0 is the only number you're allowed to use in this trivial ring. That's why it's called trivial. It's not very interesting. It's because if you want to do addition, it's not going to be well defined if you don't have an identity. Because if you don't have an identity, you don't have inverses either. So, I mean, you could theoretically drop that, but you're dropping a lot of stuff at the same time. Well, I guess if you don't want to care about inverses. Really? That's weird to me. Okay. Maybe listen to ultra products instead. Uh, Neon VFX has a geometry question. That I probably can't do. Okay, Neon, I just quickly Googled it. I can't do this question, I'm sorry. Oops. It was. That's why I Googled it. Okay, we can keep this conversation going. I'm going to do this integral at the same time, though. I always try to do this integral. So what I just done was I found the branch cut for this function. Now that we know the branch cut, we get to actually draw the contour. So from -1 to 1, this is the z plane. We have a branch cut here. We're going to draw a dog bone or a dumbbell contour, whatever you want to call it. You do a slightly better job of drawing it. That's a circle. You're going to have to trust me there. That's another circle. You're going to have to trust me. It's oriented like that. C1, C2, C3, C4. It did, Zach. So like this, I kind of scared to believe it. But like the scores got posted to like the course canvas. So it's not the actual grade. That's like I'm not gonna believe it until I see it on the transcript. But I somehow apparently I got 85 points out of 90 on the final, which is like I thought I was going to get like 75 or 70. But I'm trying not to get excited about it because that's just like kind of that feels way too good to be true. I oriented that contour wrong. Don draws circles. Yeah, I was wondering why you were clipping that. Yeah, the circles are so hard to draw. So theoretically, looking at all my homework grades too, I'm gonna get a 96 in the class or something, like 96%. it's really generous grading if I actually got that grade on the final. For yeah, something like that. You have a bachelor since early this week. Oh, congratulations, Ultra Products. It's like a dog treat. Yeah, that it actually they call it a dog bone contour. Some people do because it looks like a dog treat. But yeah, so like I got the complete wrong answer for this exact problem that I'm working on here. I want to figure out what the right answer is, which is why I'm doing it. I got the complete wrong answer, and I only lost 5 points out of 30. Which, again, that's why I almost believe that seems so like generous. Since I knew I got the wrong answer during the test, I made sure to do a good job of doing all this justification stuff, including what I'm about to do with the contour. So I could at least have a good chance at partial credit, but like, God, that's a lot of partial credit. 0.5 kg weight contour. Okay, so the thing that we want the thing we actually want with the contour is C1. That's what we're gonna solve for, because that's one that actually matches the bounds of the integral we're given. But we need to consider all the other pieces of the contour also. I guess we're going to start with C1 though, because we want to express that in a certain way. So on C1, we need to go back to our local polar coordinates. Z minus 1. No, sorry. I still don't completely understand this part. I'm just kind of copying what we did in my notes for a similar problem. We're saying x minus 1 is equal to z minus 1. In z minus 1, we already defined it to be r1 e to the I theta 1. But then r1 has to be a positive number. And so r1 is going to equal 1 minus x. Because on this contour, 1 minus x is a positive number. X minus 1 is not positive. And we want this to be 1 minus x because that's going to make it match the original problem. Because I start off by flipping the sign inside of the square root, but that was to apparently make this part easier. I still don't really understand it, to be honest. But yeah, so r1 is 1 minus x, theta 1 is going to be pi, because it's the angle measured from here. Still in high school with a bit of extracurricular mathematics at my disposal. Might be a little ambitious to me wanting to solve such a hard and solved problem, but hey, you can dream. Yeah, I say just keep thinking about it. Like, it may not go anywhere or come out to be anything, but it's, if you're curious about it, you should keep on thinking about it. Gonna blow my mind on something else. All right, have fun, Lucas. You have a good night too. Their wheels were getting divided by 0. You'll ever seen them mention the concept being able to divide by 0. Okay. Yeah, I mean, probably it's not a huge chance of going somewhere, but maybe. Siercar, thank you so much for the follow. Sorry, the raid. I don't know why my alert didn't go off. That's so strange. What were you doing? I gotta say, I don't think I've... Your name sounds a little bit familiar, but I'm not sure that I'm familiar with your stream. Welcome in, though. I appreciate it. For anyone who's new here... Oh, hey, there's the alert. Just took a second. Oh, and thank you for the follow, also. Got bored, started playing crappy music? Okay, fair enough. So yeah, for anyone who's new here, my name is Don. I do math streams, or basically anyone can ask me a question I'll do my best to answer it. Hey, listen. So right now, I was just working on a problem that was from a final exam that I just did because I'm working on a master's in applied math. But today we've talked about a bunch of different things. We talked about linear algebra and matrices. With Lucas, we were talking about can we divide by 0 and make it work in math? We haven't been able to find anything, but you know, just still like talking about it and thinking about it. Oh yeah, we also did this triple integral in polar coordinates. Someone asked me that. I forget who now. It turned out to be not that bad. May headers from divided. Yeah, it's a lot to think about. I'm a huge fan of spherical. It was a little bit weird with this problem. I got tripped up on it because I'm kind of rusty on it. The person who asked the question had a good trick though, where they knew to, or they suggested integrating in Z first to make it a two-dimensional problem, and then from there use regular polar coordinates, and that made it a lot simpler to translate things. Econometrics. Is that different from economics? I haven't heard that exact word. Statistical economics. Okay, that makes sense from the name. 90% of his regression analysis. Okay. That sounds neat. Econometrics. Like there's probably a lot that can be done there. Kind of a build your own bullcrap though. I was about to say that this seems like a really noble idea for a field with because economics as I understand it can be a little wishy-washy, and statistics is probably a nice thing to base it on in theory, but you can also tell a bunch of lies with statistics if you know, twist the numbers correctly. But there's definitely, I can imagine there's a lot of like cool things to learn here and cool applications of statistical methods. Turning words and sentences into math and numbers, always gonna be imperfect. Yeah, that is the truth. Delta unemployment. Oh yeah, that is kind of funny to just like see that there. But yeah, I guess I mean the change in unemployment based on growth in the GDP. Okun's law. I mean, that's pretty cool. I can imagine there's a whole lot of correlation and causation issues here with like... You definitely shouldn't say unemployment is only affected by growth in GDP, but that is an interesting relationship that's pretty correlated. Doesn't stop some people from just plain lying. Oh yeah, that's always like the difficult thing. You have to prove that they're lying and that they knew that they were lying. Regression to eliminate those. The way you make your model can change that? Okay, that makes sense. Have new stock in sun hats. Probably used to kind of drift me towards econometrics because he thought econometrics was the hardest study there was. Really? I think I don't think you can say anything is the hardest. It's all just different. Mostly harmless econometrics. Didn't finish my degree, but it's stats. The hard part, determining what function fits your model the most. Oh, yeah, that makes sense. Extremely finance bro. That, yeah, I can imagine that would happen. Hey, the Lucas critique. Lucas, I didn't know that you had a critique for econometrics. The hardest subject is the one you have zero interest in? Yeah, that's the truth. Jetburn. Yeah. I wouldn't say I'm, like, super familiar with them, but, like, I know the basics. If you have a question, feel free to post it. You're always critical. What can I say? Stock market risk analysis? Okay. Yeah. And yeah, I can see people thinking thinking that they have the formula cracked. Or telling people that they have the formula cracked so that they do something, but then they do the opposite to profit from it or something. I don't know. Yeah, Lucas is the surname, I think. Robert Lucas. Fundamental methods of mathematical economics. Let's see. Fundamental. Yeah, surname is last name. Let's see. Oh, maybe I found it. Fomenting? Oh, yeah. Someone said, yeah. Some people put the family name first. Your names could be Lucas Lucas. It could. Oh, wow. Holy crap, this is a giant book. Fourier series expansion for the periodic function. The notation for that looks a little weird, Jetburn. Something maybe got butchered in the copy paste. 1 plus 2. I think I can do that question, but I don't know if I'm reading it right. Is the issue. uh, f of x, the periodic function. No, I'm sorry. I need you to rewrite that because I really don't know, like, 1 plus 2 less. I don't know how to translate that into something that actually makes sense. I'm sorry. Asset price dynamics. Taylor. Okay. Yeah, it's kind of cool to see like what math they're relying on here. It's all stochastic. Okay. Oh, random walks. Those are cool. Yeah, I've heard that they have like that they can be used in economics. A vol index. Yeah, this is I don't know most any of these economics terms. Markov chains, ooh, we like those. It's kind of fluffy, yeah. Basics of econometric regressions. God, I don't know why it's so hard for me to say. The Wiener process. Okay, you can't put that in your table of contents. Expect me not to giggle. That's true. Yeah, Markov chains are used for a lot of things. That's cool. I'm not much of like an economics slash finance person, but I am an applied math person, and I always love to see where that the math that I'm learning does have actual applications to things. This book felt like big math for finance bros. Yeah, it seems like it's using a lot of math. Which is good, but it's also misleading when like, because like you can base something on a lot of math, but it's still like a load of BS. But it looks legit because it uses so much math. Yes, sounds good. I can promise you I will get confused with like the economics terms, econometrics terms. Um, and some of this is kind of like at the edge of my knowledge. Like random walks, I've kind of like only dipped into a bit. Markup chains, I've like also like I know the basics of them, and I can do some things with them. But like I'll have to do some googling. But yeah, if you ever anything come up, feel free to just like try me, and I'll see what I can do. You can follow it, but you can't do it. That's fair. It is a lot easier to read a proof than it is to come up with a proof. Conversation education. Oh, okay. Fair. Yeah, there's like there's like a little niche of us like math streamers here. None of us have done like a ton of anything that's related to econometrics, but like Academies of Ideas has done some streams about like finance math and stuff like that. But it is kind of like a gap in the Twitch math niche that we have here of we don't have anyone who's like super into this type of stuff, which is I think it'd be better if we did. Yeah. I mean, you don't have to be good at math to stream it, but yeah, it is like it does make people like uncomfortable to try to do that. Um, Anyways, that list is super overwhelming. I just use that list as a way to let people know that the niche exists. That's fair. Yes, Stuki is studying, and I think still is, maybe still is, studying accounting, but that's entirely separate from their math endeavors. And accounting isn't, it involves numbers, but it's not really math. That's fair. That's probably a cool basis for a stream too. No hate. Okay, so I forgot the person's name. The person has to be Jetburn. I'm pretty sure I can do your question, but I need you to like type the question so it makes sense because the formatting of it got so butchered. As soon as you do that, I'll work on it. Until then, I'm going to go back to doing my own question. Oh yeah, this is an interesting time for to be into politics. I don't usually get like deep into it here because it kind of causes a lot of arguments, but there's definitely no shortage of things to talk about these days. Hey, Energy DeHampter, welcome in. Oh yeah, Obi, go ahead, steal it. Yeah, I'll sometimes make my references or like snide remarks or like a joke about politics, but so it's not like a super like strict rule or anything. But it does have a way of like taking over the conversation. So unless the stream is like explicitly about politics, it can like totally like derail the stream sometimes because people get so like into it. So stream because Trump is dangerous. That's fair. I think it's politics in a way. Yeah, no worries here, Car. And yeah, sorry, I hope I haven't been like keeping you here. If you ever want to like raid and run, please do. I understand. Thank you again, and I'll see you. Do I discuss mathematical physics out of curiosity? I would try to. I haven't specifically studied mathematical physics. If there's a specific part of that you want to talk about, let me know, and I can tell you if I do or don't know it. Sounds good, Sukar. Thanks again. Generally, if you think the political solution is my way or the highway, yeah. So my perspective on string theory. Ooh. Yeah, so that's out of my wheelhouse. I've studied some physics, but I haven't gone like super deep into it. Like I've just scratched the surface of general relativity, vibrations in 15D. So I can repeat other people's opinions who I respect, which is that string theory is kind of like it doesn't make that much sense, or like it's very flawed, but we don't necessarily have a better alternative to its credit. I haven't studied it for myself though, so I have a hard time saying. There's a person, yeah, I haven't seen him around in my chat for a while, but he'll kind of float around the math chat, who I think is studies string theory a lot. It's like his name is ADS3 something something. It's an acronym that has something to do with string theory. If you ever catch that person in the chat, they might have an opinion, like a more studied opinion than me. But yeah, I don't know. Thanks for trying with me. I'm sorry I don't have a better answer for you. You have run through the armchair cosmology about 15,000 times. The crisis in I haven't heard of that, Obi. Crisis in cosmology updated those odds. Yeah, I'm not sure what that is. Looking into trigonometry, someone created trigonometry park model. So we're gonna do the same, but for algebra. I feel like I've heard the term park model. I don't remember what it is. I'm getting mobile home parks when I Google this near me. That's not what I want. Park model math? Nothing comes up with that. I'm not sure what you mean by that, famous troll. Maybe I should get a mobile home though. let's see. Trigonometry. Oh, just like a diorama showing trig identities? I want to see the thing working. Oh, so this is just basically a quiz. Okay. Uh, yeah, I mean, I thought it was gonna be like a demonstration of why certain things should be true. That's like a it looks nice. I don't know if it would help me learn personally, but it's cool. To my understanding, correct me if I'm mistaken, the math that relates to Einstein's theory of relativity involves differential geometry. Yeah, that's my understanding too. So yeah, I've basically had an attempt at studying general relativity. I got like into chapter 8 or 9 of a textbook on it. So for what it's worth, that's the extent of my knowledge. But the basic idea is, as I understand it, is that gravity isn't a force. It's just curvature in space time. Oh yeah, yeah. I can like introduce you to it. Do you, just as a question, do you know calculus and like specifically multivariable calculus? If not, I can still teach you something. I'm trying to figure out what your background is though. If you don't get at math, it's actually really easy. Then it says stop trying to understand on the side. That is rich B. Yes, morbids? Okay. The Hubble constant expansion rate of the universe could have been one of two values. There's something like 15 sigma chance. Oh, I didn't know about that. You know calculus but not multivariable? Okay, cool. That's enough. Just do chemistry instead? True. Okay, so the fundamental thing with general relativity, as I understand it, is that gravity is not a force. It is all just geometry. Space-time itself is curved, and an object basically in free fall with no forces acting on it just moves in the shortest path possible. But because space itself is curved, the shortest path is also curved. And differential geometry is how we describe that curvature. And so I'll warn you, I only know the basics of this. I don't know anything about tensors. But they're in there somewhere. Where I would start with this conversation, though, is the Pythagorean theorem. So a squared plus b squared equals c squared. If space is not curved, the Pythagorean theorem is perfect. This is and it basically says you know, the sides of you can relate the sides of a right triangle to the hypotenuse, and you can think of the hypotenuse as like a measure of distance from this point to this point. But when space is curved, we need to change this formula a bit. And so now I'm trying to figure out how to explain this to someone who doesn't, or like I'm trying to square away the multivariable calculus part of this, because you know regular calculus. Something applied high data week. Yeah, Dr. Becky Smethurst, many others, Smethurst, I don't know. Was the implication this is actually a crisis? Physicists stop being allowed to name things. I wish I was high on pot news. Um, yeah, so it's gonna be making like the same point in a different way, but like uh, one of the first examples they'll show you of a curved geometry is a sphere, because that's basically the Earth that we live on. If if you try to draw a triangle on a sphere, it's just kind of different. Like the actual lines of your triangle are now curved. And the bigger the triangle is relative to the sphere, the like if your triangle is really small, you can approximate it with a flat triangle, and the Pythagorean theorem is still really close to true. But the bigger the triangle is, the less accurate it gets. Which is an idea that comes up again in like other like you can use that idea in kind of like any curve space. But I think the direction that I want to take this is let me find the formula for arc length, because that's a thing that you normally learn in single variable calculus. Arc length. Um, okay, so if we want to find the arc length of a function, this is going to build into differential geometry, I promise. If we want to find the arc length of a function, we kind of break it up into these linear pieces. And let me just kind of reproduce it more or less. You break it up into a bunch of linear pieces, and you're basically adding up all of those linear lengths. And the point of integration is that you can make these lengths like arbitrarily small to the point where they get you the exact correct value. So let's pretend each of these is the same length, and they're like there's some length s. By the Pythagorean theorem, you can always divide up that length into two legs that are parallel to x and y. So we can say s squared is equal to x squared plus y squared. But that's not exactly true. Like we need to make sure these are very, very tiny for this formula to be right, because this is ultimately a curved thing that we're approximating with straight lines. And so it's only ever going to be perfectly accurate when they're very tiny lengths. I think something's going to go slightly wrong with this, the more that I think about it. Well, for the next step that I wanted to do. Yeah, there's gonna be a little bit of a flaw in this, but once you get into like no, I want to relate this to the formula for arc length, but it's not quite working out in my head. And so I might forget about the arc length for now, because this is still kind of the basic idea for how you can measure the length of a curve. You break it up into very arbitrarily small lines that follow the curve, and you break up those arbitrarily small lines into components along your axes, so you can actually calculate those distances easily. So in a sense, like, you could somehow get from this to the formula for arc length. That's the part that I'm getting confused on. And sorry, when I say the formula, actually, I already showed that, right? I'm pausing my notes. Like, this is the thing that is usually pretty common to get taught in a calculus class. Oh, wait, now I see it. Okay. What they do is they solve it for ds. So you take the square root of each side, dx squared plus dy squared. And then you factor a dx squared out. And then the square root, this dx squared can come outside of the square root as long as it gets square rooted. Dx. Okay. And so really the point of me doing this is that we can go from basically the Pythagorean theorem. We can apply that to measuring the length of a curve. That's the important thing of why I started with this, because we can integrate over ds. I'm instead of saying from 0 to 1 like you might be used to, or like from one number to another from one number to another number, I'm gonna say we're integrating over some curve c, and we don't worry about bounds. Like, we can't directly evaluate this integral, we need to change it, but that's okay. The way that you would proceed is you'd use the formula we just found here and say that the length of the curve S is equal to the integral on the curve with infinitely small lines, and that's equal to this formula that we found. And this would be from A to B. And that's an integral that you can evaluate in theory. Okay, so this is all for Euclidean geometry, meaning it's a flat plane. There's no curved space yet. Where we do get into curved space is when we ask the question, what if we take this basically Pythagorean theorem and we make it something else? Like, we modify it. You could just make that a minus sign, or you could put like, I don't know, sine of x or something random. Like, any modification to this makes things non-Euclidean. And so I should say that we don't normally have just x and y. And if you have 3 dimensions, a version of the Pythagorean theorem still holds, where you just have now a dz. And so where you get into special relativity is that these are 3 dimensions of space. The fundamental thing that special relativity does is it considers basically time to be another dimension here. Not of space, but there's probably a deep explanation for this that I don't know. But we're gonna basically include time in this as a part of our measure of distance. So we're no longer measuring distance in space, we're measuring distance in space-time. So ds squared, and there's two different versions of this. The one that's coming to mind right now is minus dt squared plus dx squared plus dy squared plus dz squared. The alternative thing, this is just a matter of opinion, which one you take as your definition. You could do it with the signs all flipped. It's kind of a matter of style. And so let me write this. Distance in space is the first thing. Distance in space-time is the second thing. And I think if you ask, I studied differential geometry through a physics lens. If you ask a mathematician to explain it, they would probably give you a more general explanation that doesn't go into space and space-time directly. I imagine this is part of it that I haven't studied it through a mathematical lens, so I can't give that explanation. And I imagine you're more interested in the physics one anyway, though. So yeah, there's already a lot to understand with this. This is the fundamental thing that special relativity does. This is called flat space-time. It's not Euclidean, but it's not very crazy. Like, this is called a metric. That, like, you can get some really crazy metrics in general relativity, but you kind of start with this one, which is just flat space-time, but it's not flat geometry because of the minus sign. And so you can, because there's a minus sign there, you can get weird things like, you draw these space-time diagrams where it's going to take a two-dimensional impression. So forget about y and z for now and just do x and t. Where there's this like weird thing where anything on this line, like x equals t, a point here and a point here are separated by zero distance in space-time. Any set of points that are on this like same slope, I think even for the other way too. So even like any points on that slope. I think that part is right. And so you can kind of get like, there's a region of points that happens here where like everything in this kind of quadrant, ooh, I might be saying something that's slightly wrong, but like everything like this kind of like quadrant is separated in these two quadrants are separated by time, and everything in these other two are separated kind of more by space. And when I say separated by, I mean like, is the dt term bigger or is the dx term bigger? And I might have this drawing slightly wrong, but it's something like this, where like you can have things that are separated primarily because of the difference in time or primarily because of the difference in space. No, Ryan Wilsh, we're talking about non-Euclidean geometry. And so drawing something non-Euclidean on this flat surface is inherently misleading. You need to go back to this formula when you want to actually measure the distance between things. You should not rely on this like picture here to measure distance, because like I said before, like this point here and this point here are actually distance zero from each other. but they're clearly like not the same point. So what the hell? Exactly, yeah. We're choosing a new way to measure distance that's different from the old way that we're used to. And so this idea that we can play around with our measure for distance is the basis for differential geometry. So at this point, I think I'm going to bring up a textbook because I want to show you some metrics. Actually, wait, I want to do one more thing. Just like we did up here for the formula for arc length, you can do with this for distance in non-Euclidean space. So if you want to define some path through space-time, like from here to there, you can do the same thing of breaking it up into little pieces and adding up those pieces. And you can do that with integration. The s distance in space-time is equal to the integral on that curve is equal to, like, you know, some integral from a to b of root this like complicated thing. Bobos, hello, good evening. 3x3x3 tic-tac-toe is undrawable? I can imagine drawing it. Maybe I don't know what that means though. Untieable. Oh, okay. I was like, okay, that makes a lot more sense. Same, Phobos. It's gonna be kind of crazy. I was bashing the list. So I gotta admit, with most of those languages, I've only heard the name and I don't know anything about them. So it's gonna be a wild ride. It's got, yeah, sequel I think wouldn't be possible. So I guess okay, so it gets a little more complicated to do this arc length thing when you have so many more variables, but you can do it. You're basically, you can usually choose to take the dt out. You don't have to though, and you can even define some other variable entirely, which is sometimes advantageous. Actually, it's often advantageous. Yeah, I'm gonna leave that. I'll leave it to your imagination. Yeah, so ultra products. Tomorrow at 10 a.m. Pacific time, there's gonna be a competition with myself, Phobos, and Zach. It's just like for fun, friendly programming competition. We've had like 3 or 4 of them in total now. We're gonna take problems from the Advent of Code website. And I'll get a random programming language that we have to solve them in. And so I haven't programmed in most of the languages that are on the list, so it's going to be a hell of a time. Yeah. And so I'll keep on with the explanation on differential geometry in a second here. We don't get Perl or closure. I didn't. What was on the list even? I forgot already. Oh God, yeah. I hope I just skip Python and Java. I guess C# I could handle too. C++. All the others I don't know. Turing machine? Okay, okay, yeah, so this is the part where I want to open up a textbook now. So, Energy, I hope I haven't lost you. If I have, please do let me know, and I'm happy to go back and explain it again. Where's my book? There we go. Okay. So earlier this year, like in spring and summer, I did a whole reading group on this book where myself and a member of the community called Fembox met every week to talk about this book and do problems from it. And I just want to show a few examples of metrics for interesting geometries. There's a few fun things with Markov algorithms. Okay. Where's my bookmarks? Why am I scrolling through here like a peasant? Here we go. God, I remember that. Oh my God, I'm getting PTSD from reading this. This is so freaking complicated. Um, where did they talk about the geometry of a sphere? I don't. Okay, yeah. So this is an example of a line element for if you existed on a sphere. So like for Earth, this would be a pretty good approximation. The Earth isn't perfectly spherical, but if it was, this would be exactly it. So you don't need a radius because if you're just living on the surface of the sphere, you're always at the same radius. So you only need 2 angles. And depending which angle you're at, you can, like which angle you start from, what angle you end at for those 2 coordinates, you can get a distance between those 2 points. I was going to learn C++. I figured to finish up with Java. We're going to, yeah, you should definitely, I would recommend like getting comfortable with Java before you move on to another one. You know, total of 1 programming language entirely impossible to guess what it is. So one of those meme ones like brainfuck or whatever. This makes sense. So to clarify, no, not area. You could get the area of shapes in curved geometry, but that's a little bit harder. This is all about distance. And this is the distance from, this is for flat space. So Euclidean geometry, no curvature. The distance from one 3-dimensional point to another 3-dimensional point in Euclidean geometry is this thing that I have here and that you wrote in chat. So as long as it looks like the Pythagorean theorem, where things are squared and you have pluses, and there's nothing special going on, that's always Euclidean. And so like, this looks like the Pythagorean theorem, you just have one extra thing. Yeah, it was really interesting to study it, but God, it was so difficult. And so as soon as you start messing with signs or adding in functions or whatever, that's when things get non-Euclidean. So this becomes, with this S, we are only ever measuring distance. We're not talking about area at all. This was the first example I've showed of a non-Euclidean distance. It's not Euclidean because of the minus sign there. Oh yeah, Mistral, I can do that. It might still be posted in my Discord server. I might be able to find the message. Oh, it's Python? Okay, you're being ironic. So yeah, and the reason I was talking about triangles is that the thing that we're measuring is the hypotenuse of the triangle. So like really we only care about that line segment, the only reason to talk about triangles is because we break up line segments into like other pieces. In 2 dimensions, we break it up into 2 pieces. In 3 dimensions, we have to break it up into 3 pieces. So it's a little bit more complicated, but if you want to measure like distance from the origin, well, no. Yes, distance from the origin like out to here. You need a piece that's parallel to x, a component that's parallel to y, and a component that's parallel to z. And then you can get the distance from one point to another. Basically, yes. Yes. And so curved space, the only thing I would add there is curved space is not just one thing. There's a whole world of different curvatures you can have. This is the most basic one they study in physics. It's called flat, but it's not technically flat. This is called like flat spacetime or the Minkowski metric. And it's fundamental to special relativity. When you make this more complicated, you get general relativity. And so an example of a more complicated geometry is the geometry of a sphere. That's what I was talking about before. So this one, it doesn't involve time. This is just space. But yeah, if you want to calculate distance on the surface of a sphere, this is the basic formula you would start with. You can. So yeah, I think okay, yeah. So yeah, I think that's kind of what I had to say about it. There is one more thing that I could show you, which is a more true example of a curved spacetime. I'm trying to find it. Okay, yeah. So they can get way, way crazier than this. I don't know what this represents, but just to give you a taste of how like curved things can get, like, or how crazy the formulas can get, like this is like a taste of it. So and by looking at this, you can tell certain properties about the curvature of this. Like this part over here looks a lot like spherical space. So I expect it to have some type of symmetry like a sphere does, but I don't know what's happening around here. So it's something that's more complicated than just a sphere. But yeah, I guess the thing that the reason for me showing this to you is that this has the same pattern as I just showed you with the Minkowski metric for flat spacetime. You have a ds squared, you have a negative dt squared, a dr squared, which could be also dx, a d theta squared, which could be your dy, and a d phi squared, which could be your dz. Like the letter itself isn't too important. Just that's like the base that you evolve things from. How does one find the derivative of a function? Oh yeah, so there's basically a bunch of different rules. Oh, and I guess I maybe should have made it more clear. When I put the letter D in front of a variable, it means to make it very small. So a very small distance is equal to a very small distance in x plus a very small distance in y squared plus a very small distance in z squared. Okay, so the derivative of a function. It revolves like so basically there's only like 12 or something functions that we really like 12 basic functions that we really care about in math. It's somewhere around there. So everything else is just a combination of those basic functions. So we kind of have just a bunch of rules for how to handle the different combinations. Let's start off with like one of the basic functions, like a polynomial. If f of x is equal to 2x squared minus 3x plus 1, and we want to find f prime x. Prime is the derivative. So if you to start with, to take the derivative of this, you can just go term by term. So we can start looking just at the 2x squared only. And even then, the 2 in front doesn't really matter. It can just stay out front, and we only have to worry about the derivative of x squared. So I'm going to put this 2 here, and then inside the parentheses will be the derivative of x squared. So this is the power rule. For the power rule, is when you have x to a number. So the power comes down, and then you subtract 1 from the power. So derivative of x squared is 2 times x to the 1. But usually we don't write the 1. So just 2x. So again, the power comes down, subtract 1 from the exponent. So now we can go to the next term, minus 3x. The minus 3 can stay out front, worry just about the x. We can apply the power rule to x as well. That's like x to the 1. So the 1 comes down, and then 1 minus 1 is 0. So x to the 0 is 1. So we really just get 1 when we take the derivative of x. And finally, for the derivative of 1, that's just a constant. It actually becomes 0. So I wrote this weird, but now we can clean it up. 2 times 2x is 4x. 3 times 1 is 3. And plus 0 doesn't matter. That's usually what they teach you in a calculus class for like how you find the derivative of a polynomial. They all come from the definition of a derivative, which there's different versions of it. But fundamentally, like what we just did up here, you could derive from this formula that or this definition that I'm written here. And another common one is this one here. Oh yeah, there's a bunch of good videos on that stuff. The channel Floathead Physics has a lot of good ones too. Oh, it probably does, Flofi, yeah. I like the second one a lot more for intuition. So yeah, I guess it's different rules that you learn for different types of functions. So unless you want to use one of these formulas every time, you just kind of know that if your function is sine of x, the derivative is cosine. Dude, I don't know what I'm writing. I'm getting tired, I guess. Um, so practically it comes from a lot of memorization. If you have the natural log of x, the derivative is 1 over x is an important one. How the function from multivariable calculus worked out. Pretty nice in proofs. Okay, the multivariable chain rule is, it's really deep, and I have a hard time really wrapping my head around it. I can use it, but there's a lot to it. We should talk about the chain rule though. So if you have, oh sorry, what is that, ln? It's natural log or natural logarithm, and I'll explain that too. If you remember what a logarithm is, and you remember what the number e is, it is log base e of x. So log is a function, e is a number. E is an irrational number like pi. Pi is 3.14 something. E is 2.71 something. You know E, but you don't know. Okay. Logarithm, honestly, it's not too important for this discussion, but a logarithm is it has to do with exponents. If I have the equation 2 cubed equals 8, I can write a completely equivalent equation, which is log base 2 of 8 equals 3. So a log gets you the exponent. Like your base is 2, what power do you need to get 8? The answer is 3. That's what a logarithm does for you. And it's nice if you have a situation where like 3 to the x equals 11. You would need logs to solve this equation. But it's not like super important. I was just like showing an example of a derivative. Oh, I've seen definitions like that. Like there's generalized definitions of the derivative that look a lot like the one that I wrote here, but they're more advanced. See, energy, I think you probably learned too is the chain rule. If you have the composition of two functions we know the derivative of, there's a way that you can find that. So let's say we have sine of x squared. We want to find the derivative of that. Oh no, energy. There's no question that's too basic. People have a tendency to ask really hard questions, and I sit here stumped and feeling stupid. I would so much rather explain this all day than just like be confused about some crazy math that someone is doing. I should have written the actual formula. If you have f of g of x prime, the chain rule tells you that the derivative is f prime of g of x times g prime of x, and it's kind of confusing. I think it's easier to see an example. I wrote this. It also helps if I don't have terrible handwriting. So here the outside function is sine, the inside function is x squared. And so I think of it as going from the outside in. So pretend we had just x. The derivative of a sine is cosine. And then keep what's inside the parentheses the same though, like x squared still has to be there. But then the chain rule tells you we have to multiply by the derivative of the inside. So the derivative of x squared is 2x. And maybe I should have done that too to make it more clear what's being primed. So just rearrange this and that's your answer, 2x cosine x squared. See, like power rule and chain rule are two like common ones. Like I can go through more, but I'm not sure how specific of an answer you're looking for. Almost perfect. Derivative power rule, you got that right. X to the n prime is n x to the n minus 1. But the integral of x to the n is actually x to the n plus 1 over n plus 1. So just the plus 1 that you're missing there. And you could verify that by taking the derivative of this, and you should get the inside of the integral. And I was showing you really bit before when we were talking about differential geometry. But this website in general, Paul's online notes, if you're just looking for like a refresher on calculus, it does a really good job. So if I'm ever like not around and you want a refresher on some concept in calculus, it's a good place to go. Your internet did go out? Oh no. Okay, but you just got to see the first round of 16. Okay, I'm glad you just like got a chance to like raid Zach and be here. Good to see it. Yes. The integral of x squared dx is x cubed over 3. There is a little caveat where you add the constant plus c. Yeah, Flip said at the same time. The reason that you do that is because, exactly as Flippy says, if I have x cubed over 3 and I take the derivative of that, we use the power rule, the 3 comes down, it cancels with that 3. That's all well and good. We get x squared. So this x squared matches that x squared. That's good news. The bad news is that if I had x cubed over 3 plus 1 prime, we do the same process that I showed up at the top of the page. Take the derivative of this, that's x squared. But the derivative of 1 is 0. So we also get x squared. That's why we do the plus c, because different functions can have the same derivative if you add a constant. So derivatives, you never have any ambiguity. The integrals you do. It's this weird like one directional thing. Okay, good. I might want to wrap things up soon because I'm getting it's like a little bit like tired and hungry. But do you have anything else that you want to ask? Energy? Because I can stick around to explain another thing if you want. But shouldn't math because I mentioned in philosophy. I don't have very much background, but I'd say that I'm getting interested in it. So I actually just announced next Thursday, starting 4 hours and 13 minutes ago, whatever that is in your time zone, myself, Academy of Useless Ideas, and anyone who wants to join us on voice are gonna... Oh, I misspelled it. Academy of Useless Ideas. are gonna hop on voice and talk about a book. Thinking about mathematics, the philosophy of math by Stuart Shapiro. So I'm not very far in the book at all. Neither is Slim. But it's a really good book so far. It's really dense. I've never studied philosophy before, but it's pretty interesting. So I say that I don't know much about it, but I've gotten interested in it. Gives you anxiety. It is a lot. There's a ton of terms that I've just never heard of before. It's really the vocabulary is a lot. Oh, but you mean for a completely different reason? Was it just like people being arrogant? And so academic ideas, he knows more about math philosophy than I do, and he's definitely interested in it. Wittgenstein, let me see if there's an index. I don't remember that name getting mentioned. Ooh. Yes, it does. I can see in the index there's like 5 different mentions of it. I don't know if it goes super in depth. But Wittgenstein has a few mentions in this book. The book is from like 1997, I think, too. So it's old enough that there should be like PDFs out there too, if you look. I just got this from the local university library, though. Whenever I disagree with something, go to retort something. Yeah, I honestly, I have that same issue when I'm reading this book where like I can't tell if this idea is stupid or if I just don't get it. I give it the benefit of the doubt that I just don't get it, but like, yeah, some of the ideas are just really weird. By math more difficult than philosophy of math? I don't know. I haven't gone deep enough into philosophy of math to be able to rate it yet. There's a lot of vocabulary to overcome, but once you can overcome it, it doesn't seem that hard so far from the little bit that I've dipped my toes in, but I don't know. It's definitely a matter of opinion too. You get deep enough into any subject? Yeah. So that's why I kind of like give it that caveat that I don't know. I know way more about math than I know about philosophy of math. Okay. I think it's a good time to wrap things up. Maybe I'm just like a natural. Yeah, I'm gonna look for a raid here. Um, I don't have anyone who's actively doing math. Um, I see Globus is doing his AI thing. We could congratulate Tinker on passing his defense. Let me do a quick scan if there's anyone who's actively doing math. Math category is empty. Oh, wait, this person. I've heard this person get talked about before. I never had a chance to watch their stream. I'm waiting through the pre-roll ad. Yeah, I'm looking at V-Enhance right now. I never had a chance to watch this person, but I think we should go say hi. Because they only just started. / raid V-Enhance. Whoa, I completely butchered that. Okay. Thanks so much everyone for hanging out with me. Thanks everyone for the questions. I'll be streaming again tomorrow for the programming competition and maybe some impromptu math afterwards. Who knows? I'll see y'all later. Drop some hearts in chat for V-Enhance or say hi or something. Whatever. And hope everyone has a good night. GG's.